Good afternoon, everybody. So I'm Paolo, and I work for Fortinet. And in particular, there's an internal division called FortiGuard, which focuses on, as you can imagine, threat intelligence platforms and services. But I'm not here to sell any Fortinet products today. I'm not going to kind of encourage you to buy any of our products. It's just like research that I've been doing since joining Fortinet last month, actually. So it's quite new. So summary of the talk is about what is a threat intelligence platform and services, what is the Cyber Threat Alliance, how do people actually share data in the alliance, how do we manage right now privacy and anonymity in the alliance, what kind of attacks people have performed in the past against anonymity. And then one of the potential solutions is to adopt differential privacy. And I will put one example, just a very educational example how you use differential privacy. There will be an example with federated machine learning and another one with homomorphic machine learning, right? And then we'll do a brief overview of what kind of which companies are working on differential privacy and some roadmap for our current platform. And then some questions at the end. Yeah, so big disclaimer, I'm not a crypto expert, so I know there are a few crypto people in this room, so please, I apologize in advance if some of the formulas are oversimplified. I've been working in cybersecurity in the last 7 years. I worked for Microsoft before and other small companies in the UK. My previous research was in AI and robotics, so I was working on prosthetics, artificial gait. This was at the MIT in Boston, so I was developing. I don't know if you see this nowadays. Those things are damn heavy. Can you imagine? That was like metal and aluminum. It was each process. It was like I don't know. It was like 20 kilo or something. So nowadays they have all these sleek, new materials. It's quite lightweight. But that was at the time. It must have been 15 years ago, something like that. If you see this today, just have a big laugh. There will be very few animation in the slides. I just don't like them. And yeah, there were no mathematicians were armed during this presentation, so I can promise you that. Yeah. I also worked on swarm intelligence, and this kind of that's why I kind of went into cybersecurity. There's a lot of applications of swarm intelligence in cybersecurity, but that's not for today. So, can I have I'll ask a few slides to raise your hands, just to get few statistics for myself. How many people know about, have actually used a threat intelligence platform in this room? Okay, 1, 2, 3, 4. That's not too bad. That's good. And yeah, so, for people that doesn't know about that, it's, I'd rather describe it by the actual functionality rather than using an official definition. But the purpose of a threat intelligence platform is to aggregate intelligence from multiple sources. And there's you can pay. There's free ones, paid ones. There are different formats and kind of stuff. But the idea is to basically curate, normalize, and ingest all these external feeds, and then integrate those data with the existing security systems or products you have. So, you might have your firewall, IPS, endpoint products, various API, and US CIM solution. And obviously, there are a lot of vendors doing that. We're not the only one. So Fortinet, we launched the TIS. There was a T before that, but they removed it because that wasn't very politically correct. So Fortinet TIS was launched last year in 2017 in June. So you can register. To be honest, you won't find much interesting stuff because it's quite new, but we're working on that. But there's other vendors which have been in this market for a longer time, so there's more data in there. this is just like a short list of, if I missed everybody in this room, please don't feel offended. There wasn't enough space. But, there's Anomaly, Palo Alto, RSA, Looking Glass, Cyber Solutions, Logarithm, FireEye, Alien Vault. They're not in any particular order, so it's not anyone better than the other ones. And so obviously, if you have a platform, it's kind of pointless if you don't have data inside your platform. So that's why you need to, it depends on your size of your company. So if you're a big company, like when I was working for Microsoft, I had telemetry for every possible customer from desktop to server. So I was ingesting huge amount of telemetry from both internal corporate networks, but also like external customers. But if you're a small company, you don't have much visibility. You have, there's no way you have to buy threat intel from somebody. And I put a few of them. So you have VirusTotal, FireEye, and A2Focus, the providers. And then, you put all these massive data set, you combine them in your platform. And then if you have a SOC, your SOC security team will basically log into this platform and do threat hunting, discover new trends, find new stuff, and so on. And they can write reports on that one. They can publish them for the industry, et cetera, et cetera. Obviously, some of them are free. Some of them, obviously, free stuff is not as good as the one you pay. But there's also paid services which are not that good. So I don't want to make any names. But the big question is, how do you trust? How do you actually monitor the quality of the feeds you get every time you buy for a new customer from a new feed, right? So it's kind of a big problem in this kind of market. But hopefully there are some solutions that I'm going to talk about. You can achieve that with differential privacy. So then you have. So these are like technologies, but you need to find a way for companies that are possibly in a competitive market to share data, but in a cooperative environment. And so there are a few alliances, Cyber Threat Alliance. So this is something that Fortinet basically built, I don't know how many years ago. And there are currently 16 partners. And I kind of managed to copy and paste all the logos there in no particular order. So, but they're all of them. They're all companies, and some of them are national telecom companies. And the entire point of having an alliance is that there is a relationship of trust between them. And obviously, there are policies in place that to avoid collusions or competition. Otherwise, I might feed you bad intel, and then you're going to publish an article. You look like a fool, and then maybe I will revenge. In the next time, we'll do the same thing. So there are policies and boards that talks about things like, but but always, obviously that's not always true because things happen, right? So this is a recent example. This was an incident that happened in 23rd of May 2018. So Cisco Talos. Anybody from Cisco Talos? There was a guy. No, it's not here today. They had much more visibility than us at ISP level, and they did some research on what this kind of IoT malware worm called VPN filter, and they wrote an article, and basically they're part of the alliance. Everybody in the alliance received a document, which is not ideal because typically you will do it within a machine readable format like sticks 1 or 2. And you receive a PDF which said, okay, this is what the malware does. These are all the C2 domains, the IP, the second IPs, first stage, second stage hashes, the actual samples and everything. But unfortunately, when I was looking at telemetry, so those samples were just given to us, I think it was midnight in UK time, and I was looking at VirusTotal, right? Those samples weren't supposed to be shared anywhere, but then suddenly you see somebody uploaded the sample on VirusTotal, right? And then you ask, must have been somebody from the alliance, right? And so things happened. Maybe it was by mistake, like the analyst didn't know about the policy, but human error is always there. There's you can't prevent that, and I mean, in theory, you can go back and find out who did it, because VirusTotal is owned by Google, and maybe Cisco talks to Google and say, but yeah, nobody did anything. It wasn't a big deal, but things happen, so it's not always as perfect as it seems. So it seems like a kind of a paradox where people say, well, okay, you have you have a data sharing platform, but like, why do you talk about privacy? Because, well, it's meant to be open and everybody needs to share, but for very good reasons, because obviously, if there are no privacy or like guarantees in place, people are not going to share their samples or audit logs. And I kind of made a sort of a ranking of file types and how sensitive they are. And many people in this room maybe will have different opinions because maybe it's very subjective. But so on the left side of the spectrum, you have data that usually vendors consider like low privacy. So if you have an external IP, that doesn't belong to any customer or to any particular vendor, so it's usually be considered to be okay as long as you don't tamper with the IP, which usually happens. You get website domains, binary files like binary compiled file. Although recently we have seen cases where the attacker having, especially for APT cases, the attacker actually had included username and passwords of the from a previous exfiltration stage from the target. So they were like NLTM hashes of the network of the customer they were targeting, right? So we're like, well, okay, so people are a little bit cautious now by sharing even like binary files, because inside the compiled binary sometimes there might be sensitive information and it's very hard to anonymize because there are no tools to do that right now. So so I put it on low, but it might change in the future, right? Sandbox detonation is kind of okay. There are cases where there are specific attack groups that they try to fingerprint the particular sandbox that they've been running to. So you find interesting strings. So in Microsoft we had a sandbox solution, and they were really targeting that one too. So it's kind of it's not low, but in the middle. Obviously, the software versions and products you use internally, kind of you don't really want to release that because everybody knows if you're vulnerable or not. Then you have emails that contains everything inside, like appointments, credit cards, but it could be everything inside. Who is sending to what? And then on the right side, which is what people generally don't share too much with the Alliance, is Windows event logs. And I've seen so many things, like when I was looking at Windows event logs, there's everything from, IP addresses, obviously. You have specific programs. When they open a new tab, you can see the URL from the command line. You can see hashes, like password hashes in the command line. You can see, if you have FTP, username and passwords, people are sloppy, they just put in clear username and password in command line events. Workstation names, usernames, and all sorts of stuff. Word documents, I didn't mention, but in emails, you will think, well, okay, I don't care about the I'm not going to give you the Word document, but there were examples where the Word document, the title of the document was something like meeting of the CEO with this government official in Israel, date and year, right? So that was enough to basically see what was going on in the company just by the title of the actual document. Pickups, of course, okay, IP, MAC address, URL, HTTP. Tell everything that is not inside SSL. You can get all that information, but they are easier to anonymize. Linux logs, obviously, audit logs. So people say, well, okay, so what I can do is I can anonymize all this data, right? So I can just before I send it to the threat intelligence platform, I can do some magic. I can do some shuffling. I can hash some of the fields that I don't need to. Then I send it there. There's a bunch of people in the threat intelligence platform. They do that automatically and manually. They write IP signatures, AV signatures, web signature, whatever. They do internal monitoring, then release it to their customers. There is all the signatures, hopefully as fast enough. And then maybe you discover more, and then you get this kind of positive feedback loop where you get more binaries, and you re-anonymize and you put in the platform, right? So this is kind of, looks like good in principle, but actually it's not as good as it looks like. So there is so that's anonymity. This is talking about privacy. There's two concepts in differential privacy. One is local privacy. It's quite easy to understand, and global privacy. And it's the same. You can apply the same concept to anonymizing logs. But the idea is on local privacy scenario, you add noise at source, right? So let's say you anonymize your data before you send it to a central aggregator, okay? And in differential privacy, there is a thing called randomized response that help you to do that, to achieve good guarantees in privacy. But then you have global privacy, where you put stuff first in a central database, right? And then the analyst or whoever has access to that database can only do queries which are privacy protected, right? And there's another mathematical object called Laplace noise that can help you to achieve that. Obviously, just raise your hands. Who thinks the local privacy approach is better than the global one? Oh, only one. Okay, only two. And the global one, I guess, is the opposite. There's different philosophy, but the main problem here is that if somebody hacks you, if you're using a global privacy setup, if somebody hacks your main DB, everything is in clear, right? So but with this one, right, there's no way you go back to the source and find the original data, right? But there's pros and cons, but generally the left side is more secure, the left approach, okay? So people say, well, okay, yeah, why are you talking about differential privacy? There's this concept, okay, anonymity. How many people have heard of this? Okay, some people are interesting. Since 1998, an Italian lady over there, and yeah, it didn't become very big. So it was like, yeah, it was people in the academia reading about that. Somebody implemented in a public API. I don't know if you remember this, but there was still there a website that shows, if a service was hacked and your email was in there, you can go and check if your email was hacked. And they were using k-anonymity for doing that anonymously. And the main concept is using suppression or generalization to achieve privacy, but it does not include randomization, and we'll see later why it's important. So it's and unfortunately, it's not a very good method in high-dimensional data because it's vulnerable to joining attacks. But it's a weak privacy mechanism. And there are variations of that are stronger than the vanilla algorithm. But it's kind of good to evaluate privacy vulnerability, right? So this is an example from our own logs. So this is the AV log. It's an internal database where we store information about all the customers that are running our products. So we have antivirus products. And obviously, this is anonymized in the slides already because I couldn't really put the original information. But so this is a table we have actually inside Fortinet, and there's a few more columns, but the idea is you have a serial number. So this serial number is unique. So every time you buy a FortiGate, you get a serial number. You have the company name. These are fictitious. I don't know if you have McDonald's or Disney. Probably we have, but it's just randomly. Just put it there. You have the country of the company. You have the industry, the company size, and how many detections that specific company had, right? And the detections can be, in this case, was just antivirus. So like how many times we blocked something, okay? And this is in a period of 24 hours, this table, right? And okay, so if you use you can calculate the k-anonymity for each column. And of course, serial number has a k-anon value of 1 because it's unique, so you can expect that. Customer name is 1 because if I tell you there's only one McDonald's for 3, you can only register one company in the US called McDonald's. Obviously, the number of detections is very unique, so you get 1. Industry, obviously, there are more companies in a few industries, so it's 45. But the interesting thing for me was that I didn't really think about this, is that country code, so in our database, we only have one company that belongs to a specific country. So that means that's bad, right? Because if I tell you, well, okay, one of our customers from, I'm making it up, from Trinidad, Tobago, ad detections for being infected by Loki, or it was under attack, then say, oh, hold on. So I know that Fortinet has only one customer called XYZ, in Trinidad and Tobago. So you can work out, from our official sales reports, or like the one that they give to shareholders, you can find out who bought that, and dang, so you can associate just by knowing the country. You can expand your table and you can know everything about that customer, right? So it's kind of a very good tool to assess how much anonymity you have in your database. So how do you use that? There's two main mechanisms. So you can use suppression. So you can say, well, okay, so if I have a low K anonymity score, so that was like serial number was 1, company name was 1, so you basically just blank it out, okay? I put just asterisk in there. Country is also bad because we saw that it was a score of 1, so it means I need to anonymize that, so I put stars in there. Industry was not too bad because it was like 54. And company size, you can basically round it off, if it wasn't a big problem. And detections, it was also very unique, so you can kind of do generalization, so you can break up your numbers into chunks. As you can see, this, you lost most of the information, and you can't really do a lot of machine learning on this kind of data set. You lose a lot of precision in the process, right? So, but it works on low-dimensional data. So, some real examples of how people were thinking about anonymity. There was I don't know if you remember this, 1997, there was this governor, William Well, was re-identified by joining the voter registrations in Massachusetts and the anonymized medical data that the government has published, right? And nobody thought about, at the time, it's anonymous, but they didn't think about, well, actually, if I join these two, just by looking at postcode, age, and gender, I can actually find unique records by joining these two data sets. And they calculated that 87% of the US population have unique date of birth, gender, and postal code, right? So it's quite easy to re-identify people. One recent one was the Netflix challenge, 2006. They release all these ratings, say, okay, they're fully anonymized, and we even randomize the rating so that it's more anonymous, right? But then some researcher, I can't remember from where, they say, wow, what if I take IMDb records, right? It's probably there are the same movies inside, but there are like usernames and emails, right? And they find out that, yes, just with 8 movie ratings and dates, they will be able to recover 99% of the records. So you can actually see who said a movie was crap, right? And then this was a cool one. New York taxi rides, public data set. It was FOIA disclosure. So like by law, these were not Uber. This was the taxi cabs by the New York City Council. So they had to publish this data, and then somebody said, well, what if I look at this data and go into a paparazzi website? I can see if this was Scarlett Johansson, I think, yeah. And they basically were correlating pictures from paparazzis, and they find out, well, yeah, she was there at like 3 p.m. on a Sunday, and that was the only taxi that was there in that area. And then they managed to work out how much tips did they pay to the taxi driver, where she was going. They found some interesting patterns around nightclubs and strip clubs. So it was not very nice, but yeah. So that's the stuff you can do. Mobile phone data is crazy. You can find, you can re-identify 3% of total users just with a day worth of trace data, and you can re-identify. This is a research paper, so obviously mobile phone data is intuitively is also not very anonymous. Hacks and leaks always happen. So. Ashley Madison hack in 2015. I was working in Microsoft at that time, and there was a data scientist, it wasn't me, they published a pie chart of all the major companies like Amazon, Facebook, and Microsoft, just by looking at the domain names of the emails, and they were finding like infidelity rates, like who is more infidel. I think was it Amazon or Facebook? I can't remember. But they find out, like it was a nice chart. But then what happened was internally, right? Because people had access to the aliens. I did it as well. I was looking if, if people like I knew they were on actually Madison, because you can just type the email alias in your calendar. And unfortunately, yeah, there were, managers and other people that were using the website. And I mean, nothing happened from an HR perspective, but it wasn't nice. Yeah, people made jokes like every time I was walking in the corridor. Not very nice. And one of the wives discovered, and somebody got divorced. So, there's some serious side effects when something like this happens. The 2018 leak, it was like Location Smart. They had a web survey that was open, so you can get you can put your phone number or phone of a friend. You can get all his location history. That was pretty bad as well. And all these times where companies were publishing stuff and they didn't do it properly. So like, you can open the PDF, and it was just like a layer of, it was, human errors, kind of stuff. So what do we want? So, differential privacy is about asking the right questions. So, and there's a few questions that we want to know, but without disclosing too much information. And so, for example, I want to see, for example, how many members of the alliance have seen a particular threat. And for that, you can use differential privacy. How many customers were infected? You can use differential privacy. Could we combine individual detection from every vendor to build a global better one? So you can use federated machine learning. And how good is the detection that I produce with dataset that I have never seen? So you can use homomorphic machine learning. Okay. The definition of differential privacy was embedded by Cynthia work in 2006. She was working for Microsoft at the time and still now. And it's I would say it's pretty basic. I mean, I did a little bit of probability calculus before, but the idea is that if I'm doing a survey and I have two choices, one to say yes, I'm a smoker, no, I'm not a smoker. I need to have a mechanism in place that allows me to that essentially introduce a probability error that doesn't allow me to go back to the original question, right? The way you do that is basically you introduce noise in your survey, so that the same observation could be the outcome of two different choices, right? And you can calculate this bound, and you can also calculate the privacy loss. And of course, it's not magic. So you have high privacy, you have low accuracy. You can have high accuracy and low privacy. That's the entire concept is you lose something, you gain something, right? So this is an example. Fictitious example. So I want to know if how many customers or like how many members of the alliance have seen the IPT group 37 this month, and people like customers or like members, they don't really necessarily want to disclose that they're seeing that threat actors in that specific month. So the way you could do that is basically you have each members of the alliance responds individually, and we don't have a central database because it's not a good idea. So everybody responds individually, and we shuffle the responses before they go to the central server, right? And it's a very simple protocol, and you can calculate the formula by hand. It's quite simple. So you flip a coin, right? I flip one coin. If he goes head, I tell the truth. Then I flip it another time. If he's tail, then I flip a second time, and then I say yes if it was head, or if I say no if it was tail, right? And so basically you have 50% chance in the first one, and then 25% chance in the second row, right? And so the question is, okay, so everything I get, it's in this. You can see it's Y. So this is the percentage of people that have said yes. So that's a percentage. So like 75% in the last row or 25% in the first row. And very simple formula. I mean, I did this. And it's correct. You can. It's very simple probability calculus. So you can write the direct equation, and then you just invert it, right? And so that means if 75% of our members, of our customers say yes, okay, it means that the percentage of people that really said yes is 1, so everybody said yes, right? So this is the expected outcome, right? So because it's probably, it doesn't mean it's 100%. It doesn't mean it was actually 100%. It means that if you do this experiment, this survey many times, like infinite at the limit, after many times, you will converge to that value. But every time you do a survey, it will not be that, yeah? So you have to understand, right, okay? And you can calculate these probabilities, and you can say, okay, this is the probabilities of the observer being a yes, so P of O equal to 1. Let's say it was like 60% in that case. And then the conditional probability of having that observation being yes, given the fact that the actual response was 1, it was 82%. But the opposite, so the probability of that I said yes, but I didn't say yes, is 0.33%. What that means is that there is a skew. I mean, this is a little bit hard to understand, but it's basically, it's more likely if I see a yes that you actually have said yes for real, rather than you say no, okay? So it's asymmetric, but it's still a privacy, you know, you can still do any particular inference, right? Because you can still say 100% that I said yes. I mean, this is a little bit, I mean, it takes time to digest that, but yeah. So 32 minutes. We have examples from federated learning. So this is, I took DNS logs, and the idea is you have 3 vendors. I put Cisco, Palo Alto Network, and Fortinet, and everybody sees a different, you know, they have different feeds for DNS logs, and I kind of imagine that Cisco is seeing Alexa and is seeing like Alexa domains, you know, top 100 Alexa domains, but he's also seeing CryptoLocker, right? And he can build his own logistic regression classifier on that one. Palo Alto may be seeing Alexa and GODS, which is a botnet, and Fortinet in the same period was seeing Alexa and new GODS, right? So everybody has their own classifier that is able to tell if a domain was good or bad. And the idea is that you can combine all these local classifiers. You can produce a global classifier, and then you can feed it back, right? And the way it works, it's you train your classifier in plain text, you encrypt the weights of the logistic regression, and you use basically this Pioneer crypto that was invented in 1999. You combine these weights which are encrypted, you decrypt them, you build a clear text gradient, and you send it back to each partner, right? They sum it up again, and then they retrain the classifier so that they have better predictions, okay? So trust me, it works. And to show that, I actually implemented it one version. And I took 4,500 DNS record logs, 4,000 were from Alexa, top 100 domains, well, the top 5,000 domains. I got OpenDNS, there were 52 CryptoLocker domains, 167 GODS and new GODS, roughly in the same proportion. I trained test split 80-20%, it's pretty common in machine learning. And I used logistic regression with gradient descent for like 50 iterations, with the learning of, these are all parameters. And I'm using a key size of 1024 bits, which is kind of enough for the kind of precision you need for logistic regression. And you can see that, so before this is, you know, on that slide, before it means every partner build their own classifier to classify those logs, and they achieved a certain precision recall rate. So, you know, Cisco had 84, 76, 86, 82, etc. After you combine all these models, the idea is hopefully you get something better, which did happen. So, you know, Cisco now gets 86% for both precision recall. Palo Alto, it was very unlucky, he lost a little bit on precision, but gained some little bit more on recall. In Fortinet, you know, we got 1% point more and, you know, 3% more on recall. And although they seem like small percentages, when you talk about volumes, it's quite a lot, right? I mean, even in vision machine learning, like if you have an improvement, like, you know, it's quite a lot, right? And obviously, homomorphic encryption. So Pioneer is a form of not fully homomorphic encryption, and it just takes more time. You know, it's so, you know, with Pioneer, it took me around 9 seconds on this MacBook Pro to train, you know, to do the entire the training loop. But, you know, if I was doing it without, it was 196 times faster, right? So. Then, cool things, you can also use homomorphic machine learning for email filtering. This time I took a public domain from that. I don't know if anybody remember this, but Aaron was there was an investigation many years ago by the US government because they were involved in various, let's say, not very legitimate activities, unfortunately. So what they did after the investigation, they published everything, right? And the funny thing is, like all the emails that they published from the internal corporate network, they forgot to anonymize them. So when at the time when I was looking into that, I found all the credit card numbers, social security numbers, people going to the doctor, people with cancer, that kind of stuff. And then after a month later, somebody said, well, actually, the credit card numbers. Oh shit, okay. And they took it back, so you can find the original data set. I have one, but you can, if you go now, it's not available anymore. There was a company who wrote regular expressions to remove all the credit card information, that kind of stuff. But you can download now the one without private information. So the cool thing you can do with homomorphic machine learning is, so Cisco, one of our partners say, I want to build a logistic regression model for classifying ham or spam, okay, or phishing, whatever. But I don't want to, give that to, I want to try if this model performs really well on data that I've never seen before, but I don't want to ask Fortinet to send all their email, because it's pretty sensitive. So how do I do that? So you take all your data set, which is private, you build your classifier, you encrypt it with your private key, which is the red key. Then you send the encrypted model to Fortinet. Fortinet then apply get your public key and take all these emails and produce predictions with that one, okay, with the encrypted model and your public key. So what you get out of that, you have an encrypted score. So Fortinet can see if a particular email was ham or spam because it's encrypted, okay? Then Fortinet, it's a little bit laborious, but it works. You send back the vector of encrypted scores back to Cisco. Cisco takes, again, his private key, decrypt it, and is able to see how many emails were classified as spam or ham, right? And then you can tell Fortinet, I'm pretty cool, do you want to buy this, right? Because, it's quite cool, I get, 80%, 98% accuracy. Or you can say, well, actually, Fortinet can do the same thing, and they can compare and say, so mine is better, and do you want to share the model or something like that? So, you can do, many things with it. And this was, again, with very basic Paleo crypto algorithms. And again, real example, so I took 11,000 emails from the Enron dataset. It was a little bit unbalanced, so like 27% were spam and 70% were ham. You do blah, 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 train test split. I had 7,997 words from the text. And obviously, classify is fast, prediction is fast, it's basically less than a second. You calculate when you encrypt your weights, it takes time, 115 seconds, because you have a lot of weights there. It's like almost 800 words, 8,000 words. You then send it to Fortinet. Fortinet needs to predict that with encryption, so it takes a little bit of time, so 44 seconds. Send it back to Cisco. Cisco decrypts it again, takes time, 19 seconds. But most importantly, you can see the error rate is the same because, it's basically the key size is enough to guarantee the same precision, right? And all of this was with default. I've used a very common library that, if you want, you can ask me later, doing that. And so who is doing this? There's actually not many companies doing that, and I made a list. So Google released a tool in 2014 called Rapport, which is randomized aggregated. It's like nicknames. It's not very good to remember that. But and then they used the federated learning on Gboard in last April 2017. And Rapport is basically used to detect unwanted software in Google Chrome. So apparently, I don't know if it's true, but there is a Rapport. There's a module inside Chrome that is using differential encryption, differential privacy to monitor what kind of software people are installing, right? And basically, what you have an histogram, and you can see the actual one, which is the blue one. So you can see it's kind of an exponential one, but then you have the one you get, which is privatized. You can see slightly different, but it still follow the same distribution, right? So you can still, it's private, but you can still understand things, right? And it's very good for histogram and counting. And so that's one module. And then they are using federated learning to train a global model from local models. And what they do on the Gboard, which is the keyboard on your phone where it suggests your key when you're typing something, they use the same approach. So you have a local model on your mobile phone, it gets sent to the cloud, which is all encrypted. They mix it back, they send it back, and everybody it basically gets better every time, more people you have on the system. Apple, December 2017, there's kind of a war now. Every company is like, oh, yeah, they're doing differential privacy. They have three main algorithms, count, mean, sketch, essentially, and they use it for very frivolous use case, basically discovering popular emojis, right? And you can see they wanted to compare what's popular in English and French, and I guess it's for marketing, but there's a few differences there. But also they also use it for identify high energy and memory usage in Safari, and for discovering new words, that kind of stuff. Uber, they have, believe me or not, but they're actually working on differential privacy, and they have a very cool tool called Chorus, and all it does is to rewrite queries add some noise and get the results already privatized. So you basically have a proxy that rewrites your SQL queries before you send it to your SQL database. So you can put that in between, and there's a few parameters it's in Java, Scala. It's not very easy to use, I have to warn you, but it works. I've tried it, and it's pretty cool. They put a lot of effort behind this. Microsoft, well, I knew this because I was working right before. There's a tool called PingQ. It's based on C#, and you can do sum, count, average, median for aggregation. Supports machine learning. And there's an example there, so it's quite easy. If you use link before, it's pretty intuitive. So you just use the same interface with a few modifiers. OpenMind, this is cool. There's a guy from Google who came up with this idea to combine everything. It sounds awesome. Like, oh, let's combine federated machine learning with homomorphic encryption blockchains and smart contracts. And they're building this amazing tool set that allows to build models and get paid for that with privacy and anti-tampering solution. I've tried to use it. It's not. It's still pretty much a work in progress, but he's quite clever. So I think there will be something soon working. But this combines everything together. So right now I'm not really interested in this because we're not using blockchains in our platform. So it's almost 44 minutes. Yeah. The conclusion is in terms of our platform, so I'm basically trying to build an API where everybody in the alliance can use differential privacy, federated machine learning, homomorphic machine learning, and so that if it's an API, you don't really have to implement your own solution because it takes time and it's pretty early stage. So people might use different libraries in the future because everything is quite new. So there's nothing like really production level right now. And then, so, if you want access to our platform, I can just give me an email. I can open you an account, and if you want to play with the data we already have in our system, then just send me an email. Yeah. Done.
Do we have any questions?
Wow. Oh, no, there's no. Oh, no. Is the crypto? No. Okay.
That was an amazing talk. So I'm not a machine learning expert. Actually, I barely even understand it sometimes.
Okay.
What I'm trying to understand is do some of these anonymization methods, privacy protection methods work for all machine learning methods? Because I understand there's a lot of different ways you can build models. So how flexible is this?
Yeah. So it's basically asking, can I apply homomorphic encryption to every algorithm? You can, yes. There is no reason why you couldn't because, okay, so it depends So the Pioneer scheme only supports multiplication, addition, and sum, okay? And product, sum, product and sum, right? So if you're doing something like a neural network that requires a logistic function, it's tough. You have to approximate that into a Taylor expansion. So you can't do everything right now, but the way I'm using it is that I'm just encrypting the weights of the model. So I'm not really training the actual model with homomorphic. You can do that. I mean, you can do that, but it just takes a lot of time. So this is just encrypting the weights, and then they're encrypted. I send it back, and the guy is basically decrypting the model and using that. So people have done it with neural networks, like the actual full implementation but it just takes too much time because you have to approximate all these operations in sum and additions and constants, and you have to neural networks are big. So if you have like an image, if you do deep learning, it's not something you can do with something like that you put in production for security logs. It's just forget it, right? Yeah. So yeah.
Any other questions? We have some time. No? Okay.
Okay. Thank you. Yeah.